you very much to Trescon, Mohammed Salim, of course, for the hospitality, Dubai for the great technology and networking, and of course, Huawei for the opportunity to be here. We're going to be spending the next 20 minutes together, and during this time, I'll try to give you a little bit of an appreciation of where AI is actually helping us or disrupting or causing massive innovation, and the thing that is probably quite challenging to us every day, which is actually going to work by car or by some medium of transportation. I do remember almost 22, 23, maybe a bit more years ago, I landed in Karachi to go do a presentation to all the bankers about cybersecurity. So I remember landing in the airport, but coming from Canada, the first thing you do when you sit on a car is go like this. And I looked and there was nothing there. So I go to my driver and says, "Where is the seatbelt?" He goes, "Optional." So obviously, if the seatbelt is optional today, AI plays actually an important role. So many of you probably drove here in a car, or today in Karachi you'll drive a car that not only has a seatbelt as a basic option, but has traction control, ABS, and probably some assisted navigation. If you had the chance of actually trying a Tesla, which there's a few of them roaming and you can easily book with Uber, you get an appreciation of the driverless experience. So how do we actually achieve such experience? As it was mentioned by some of the earlier presenters, it's really all about the data. So over the many years, we have gathered massive amounts of data, and we found a way to actually explore the value of this data. This used to be known as BI, eventually became big data. But of course, one of the things we realized is that we did not have enough data scientists. There's only 2,000 or 3,000 good ones around the world. Everybody's trying to steal from ones to the others. So then came a technology that has been around for at least 40 years, probably a few more. But the combination of fast networks, cheap storage, availability of specialized computing, basically enabled this artificial intelligence to now generate value to the organization. And what I call this actionable insights. Actually, I sometimes call this, in the case of traffic management, multimodal response. And I'll get to that in a second. So all this has come really as an evolution. So we had big data, artificial intelligence. Now we call this even enterprise intelligence, means that we are actually adding value to the organization. So how do we actually achieve such things? We really have to put many elements in the infrastructure to actually enable this to take place. We need to enable to have highly specialized chipsets. We need to enable devices that can capture this information with the right level of quality. We need to transport this data to where it actually needs to be stored. Sometimes this data is just too much, so we need to process it close to where it's actually captured. And cloud computing actually plays a very important role to actually make sure that AI in itself is successful. So AI by itself is not enough. It's a combination of several technologies together to actually achieve this success. So when we create an enterprise intelligence platform, sometimes we refer to this as a full stack platform. That means it addresses the various APIs in an open way that we require to run the business. We need to be able to interface with other applications in an open standards way. And this enables us to synergize between all these elements together, coming under one umbrella, under a globalized cloud. This really means that for you to achieve AI, you need to have the right ecosystem in place. Not one single company is going to be able to do all the elements of the solution. So a lot of interoperability testing needs to take place to achieve that. And from there, you achieve modern, mature solutions of AI. And obviously, there's many examples of that, some from previous speakers, when we talked about chatbots or bots that respond to text or to voice. They can recognize images or patterns. They can be trained. They can be adapted to as the situation changes. They can recognize handwriting and many other elements. And then when you apply this to the business context, you achieve a much greater productivity. More important than that, AI today is being used to generate coding, and it was alluded in previous presenters, AI is also being trained to produce other AI. Of course, any technology can be used for good or for bad. As you know, AI has been used for something called deepfakes, which actually allows you to generate bad implementations of AI, but we concentrate on the good ones. So you need to have an architecture that addresses all the elements from the ground up, from the chipset, from the portable infrastructure that you can put either on cameras or drones, to allow you to do what we call edge computing. That means to process very large amounts of information much closer to where it's being captured. For example, if you're capturing 4K video, this is extremely large flowing content, streaming content. So you cannot have enough bandwidth to achieve this to a centralized cloud processing platform. So you need to distribute the AI processing platform to achieve that. The interesting aspect also about AI is that the kind of CPUs that we use for AI are known as GPUs. How many people here have played video games before? Well, if you are playing video game today, you're probably using something called a GPU, which is a graphics processing unit. It's very good at many things. One is crypto mining, but another one is floating point instructions. When you're doing AI, you need to process much faster than a traditional CPU. We're not talking about 2 times faster. We're talking about 10 times or 100 times faster. So when you put all this power together, you achieve this kind of possible solutions. So when we create this and we bring this together into a smart city or a smart driving contest, we have many elements that come together. Logistics, vehicle, smart vehicle, safety, health, and all of these are together in an integrated platform to actually achieve the complete end-to-end solution. So let me examine some specific elements that are quite important when we talk about traffic intelligent management. We have sensors that we put on the ground, some for parking, some for detecting non-movement of traffic or accidents, some to detecting congestion. We can also put sensors in buses or other things like taxis or the normal cars. Every single car today shipping in China is mandated to actually have an RFID tag on it. That means you'll be able to figure out where this car is, how fast it's driving, and a lot of other information. This enables you a whole new generation of AI. All these changes today enable this massive transformation. As I mentioned, probably you got here either by metro, by taxi, Uber, or your car, but you always experience traffic congestion at some stage. It is not very pleasant. Also, people do traffic violations. How many people here talk while you're driving or texting or not wearing a seat belt? A few are maybe. The bad thing is that now you will not be able to escape. So I have a few friends in Dubai and a few ones in Bahrain that already got tickets from these new AI-driven smart cameras. They say, I wasn't doing anything. And they show them the picture. Oh, it's me. Oh, okay, I'm sorry. I will not do it again next time. So, and the other thing that I was referring to is what I call multimodal response. So multimodal response really means when you have an accident, you need to control many elements coming together to actually respond. On one side, maybe there is somebody injured, you need to send an ambulance. Maybe you need to send traffic cops. Maybe you need to send a rescue vehicle to remove the vehicle from where it is so that other traffic can flow. Maybe you need to, ahead of time, direct traffic so that you do not congest. As in, you know, in the Middle East, when there is an accident, everybody wants to come and take pictures, so it creates accidents on the other side of the road as well. So one accident usually tends to lead to many all at the same time. So really, this solution has many elements of architecture that come together to actually drive an end-to-end solution about reducing congestion, integrating with signal control and traffic, and then using trained models to actually achieve the right level of response. Other important elements is, I thought, is the automatic law enforcement. So as you know, if you're talking on a mobile or not wearing a seatbelt and somebody takes a picture, even a moving vehicle picture, it is very easy through a trained model to actually achieve that. The idea here is to minimize the risk to other people. So by doing this, you minimize the number of traffic deaths, accidents, and at the end of the day, everybody really benefits, or the overall society. One of the things that is really important about AI is that it's trainable. So you use things like machine learning. It's good about understanding new patterns. So if the patterns change, you can adapt over time. You can learn about weather and others, new events, the sequence of these events. All of these can be part of traffic congestion and how you respond to that. You can use either traditional or deep neural networks to achieve much better and more efficient machine learning. AI is also good about understanding patterns. Human beings can deal with 3, maybe 4 dimensions. AI is capable of dealing with 1,000 dimensions all at the same time. So imagine you're trying to train traffic management, you feed in weather, you feed in events, you feed other things that are all happening at the same time, and AI is actually able to predict things like accidents and what is the likelihood of an accident occurring in a given location. So then you can deploy the necessary resources to actually achieve success. So let me give you an example of how we apply this in the real world. So when you're traveling in a car, many things are important: travel time, delay, wait time, number of stops. So when you introduce AI into the equation, you can minimize or optimize the flow across intersections, across traffic lights, distance between cars, and all these elements come together very magically. So let me play a video for you.
It only takes a tap on the brakes to start a traffic jam. The next person brakes, and soon you have a shockwave of stop and go. Similarly, anyone can prevent them. Just travel at a steady speed, a safe distance from the car ahead of you, and avoid braking unless necessary. You'll become a shock absorber in the system, but most people don't do this. Artificial intelligence may be a solution. Researchers have shown that AI can learn to manage traffic by controlling just a few autonomous vehicles. They tested their system on figure 8s. When the scientists replaced just one of the 14 human-driven cars with an AV controlled by one of their algorithms, average car speed doubled. On ramps, replacing 10% of the cars doubled the number of cars passing through. For bottlenecks, replacing 10% of the cars increased throughput by more than 20%. In city grids, where the AI controlled lights, not cars, giving an algorithm control improved flow by 7%. Until we have self-driving cars controlling traffic for us, drivers can learn this from AI. Keep your distance and brake less. That's smart driving.
So, let's take things to a little bit more extreme. Would you like your mobile to actually control your car for you? If you remember a few years ago, a mobile was not such a powerful device. But the mobile that you carry today in your pocket is actually more powerful than the mainframe computers that we used a few years ago when I was introduced to this business.
Our smartphone is already outstanding at object recognition. So we thought, could the AI that's currently embedded in our phone pilot a car, recognize objects, instruct the car to avoid them, and could we do all of that in 5 weeks?
The first thing we had to do with the car was allow it to be robotically controlled. Then on top of that, we had to build a communication method that allows the phone to tell the car that is a specific object. So as an example, to understand the difference between a dog and a cat.
The next element that's more intelligent is then that information is used by the car to allow it to maneuver accordingly. The fact that this is built into the phone means that that recognition happens in a heartbeat.
The challenge we set ourselves with this was to really see what's possible. It's much more than driving a car. It's actually intelligent object recognition and using that intelligence to make decisions. If we can succeed in this challenge, what else is possible?
So today, it's not really about as simple as that. There's many sensors involved, but today's mobile can only just recognize image and patterns. They can actually recognize voice. And this allows you to build a whole new generation applications. Many of you have probably used things like Alexa or Google Voice, which means requires the cloud to actually do processing. So this processing can now happen directly on your phone without even having to make calls to the cloud. So much lower latency and responding to actions. So we are taking this technology and we're bringing it to create new smart cars. This is a project with Audi. And we are doing this at the complete city level. As you know, Dubai, a few years ago, was about 40,000 people in a fisherman's village. Today, Dubai is between 3 and 4 million people. Around the same time, there was a city called Shenzhen. And Shenzhen was also about the same time, 40,000, but today Shenzhen is 20 million people. So you can imagine the nightmare to be able to administer the complexity of this in the context. So traffic management is extremely important. So we created an ecosystem of about 10 different partners that came together using a Fusion Mind AI system to be trained and then remove the congestion from Shenzhen. And this enabled us to reduce the number of accidents, have much better traffic flow, have things like automated ticketing for things, seat belt, talking on the phone, and others. So at the end, the authorities and governments are much more efficient at the job they do, and they can concentrate on more critical responses that they must address. And overall, this is a really live example how this technology can come together to bring a solution that is practical and effective. This is my 20 minutes with you today. We have maybe 2 or 3 minutes for questions, and I hope you enjoyed, and looking forward to answer any questions you may have later on as well. Thank you.